Hello once again, pre-calculus. Hope you're all having a fantastic day. Today we're going to be talking about writing equations of simple graphs. Now, this is kind of stepping up what we're doing just a little bit, taking it definitely to the next level. This is going to be similar to writing equations for any other type of graph. There's a certain format that you follow. Since we're doing this with trigonometry, obviously, we're dealing with sine and cosine first. We'll learn about tangent later on. Don't worry about that just yet. But for right now, we're just dealing with sine and cosine, since those are really they're the easier ones to work with, because they're all the same size, like they're all the same shape. They all make the sine wave, or they're all sinusoidal, right? So a couple of things that we need to point out here. If you remember, you got your two formats, right? You've got your A is your amplitude on both of these. Then you've got your B is the what you're dividing by to get your period, right? Just a quick little reminder, you may want to write this down. Your period is 2 pi over B, right? B would be just the amount of space that it takes to complete a period, sorry, not the amount of space, but B is the number from the equation that will tell you how big your period is once you divide it by 2 pi. Well, if I was to take this B, and let's say we multiply the B over here, like say we didn't know B and we wanted to find B, so we multiply B, so B is gone now. You've got B times P equals 2 pi, and divide by P, you end up with B is 2 pi divided by your period. And that kind of makes sense, right? I mean, it's 2 pi divided by your period. The original period was 2 pi for sine and cosine. So it kind of makes sense that if you divide it by your new period, you'd get the value for B. So B is going to be equal to 2 pi over P. And again, that just kind of goes together. It makes sense that you're taking your original period, dividing it by the new period, and that gives you the ratio to put in for B. Okay? This right here is the key to writing simple equations. Now, when I say simple, I'm talking about we're not moving it up or down, not moving it left or right. This is just creating a greater amplitude or creating a different period. And we'll get into the moving it up and down, left and right a little later on. So it says write the equation of the trig function for the following graphs. So I've got us a graph here. The first thing that I would like to do is identify whether this is the cosine graph or the sine graph. And that is relatively easy to do. Does it go through the origin? If so, it's sine. Or is there a maximum or minimum on the origin, on the y-axis here? If so, it's cosine. So in this case, since it doesn't go through the origin, we're going to call this cosine. Cosine. Then I need to come up with my amplitude. So you always need to count to the top and to the bottom of what you think the axis is. The axis right here in the middle. You always need to go to the top and the bottom just to make sure that you're not moved up or down. For example, if the altitude was only 1 here, then it's 3 down here. Obviously, I'm shifted down 1 because my axis needs to be in the middle. So I'd have to go down 2 and then down 2 again. Now, in this case, from the maximum to the axis is 2. From the minimum to the axis is 2. So I pretty much know that's going to be an amplitude of 2. And then how long does it take to have a period? Or yeah, how long does it take to have a period? So from here, remember that your period can go from this point to the same point one cycle over. So go through one cycle back up to a maximum. Where are you at? Well, I'm at pi. So my period here is pi. So I can come up with my value for B pretty quick. Just do 2 pi over your period, which is pi, and you come up with 2. So this value for B right here for cosine is going to be 2. I'm not moving it left or right, so I don't have to worry about parentheses here. And then my amplitude is 2. 2 cosine 2x. And that's really all there is to it. These are just simple graphs. So we're just changing altitude, we're changing period, and then seeing what we can come up with. Okay? So again, I want to make sure and point out something here. This is a big note for me. When you're counting your amplitude, you have to count it down to the halfway mark. Okay? You have to count it down to the halfway mark. In other words, the halfway mark is the axis that runs through the middle of the graph. In this case, it happens to be the x-axis. So I count 2 down here, count 2 down here, that means I'm in the middle. All right? Okay, let's give a shot to another one. Excuse me. Number 2, the first thing I would like to do is identify, is it sine or is it cosine? In this case, it goes through 0, 0, so this is going to be a sine graph. Okay. Next thing I need to do is identify what the heck is going on with this graph, so let's do amplitude. So from the x-axis, I think the x-axis is in the middle here, so I'm going to test it. From the x-axis, I go up 1, 2, 3. And then to a trough, I go down 1, 2, 3. So good, it's in the middle. So my amplitude is 3. My period, how long does it take to complete one cycle? Well, from here it goes 1, 2, 3, 4. So it takes a period of 4 to complete one cycle. All right. So again, B is going to be 2 pi over 4, which is pi over 2. So I've got sine of pi over 2. We're not shifting left or right, so I can go ahead and put an x here. I've got an amplitude of 3, but there's still something missing. I know most of you can see it already, but if you can't, there's still something missing. And that's the fact that the sine wave used to go up like this, and now it's going down. So how do we fix it to make it go down at first? Well, we put a negative right here. Keep in mind, you can check this with your calculator if you want. You plug that into y equals and graph it, see if you get that. Okay. Let's move on. It's going to be a relatively short one today. All right. Here we go. First off, is it sine or cosine? Well, it doesn't go through 0, 0, so it's pretty much going to be cosine. Okay, now let's go through and figure out some stuff. I want to go from what I believe is the center, so we always start with the x-axis just to make sure. Here I have an amplitude of 4. Let's go over to a maximum, and here I have an amplitude of 4. So perfect. So that makes my amplitude 4. Now what about my period? Now this one's actually different. I need to measure from one point on the graph to the same point farther on. Well, in this case, I only have a maximum and a maximum that I can work with. So from here, I've got a half a crest, a full trough, and a half a crest. So I'm going to measure from mountaintop to mountaintop. What's the span there? What's the distance? We go from negative 2 pi to 2 pi. So that's going to be 4 pi. So ran out of space here. My value for B, oops, sorry, the pencil slipped. B is going to be 2 pi over 4 pi, which makes B 1/2. So it's going to be cosine of 1/2. We're not moving left or right, so we can just go ahead and put x. And then my amplitude is 4. But again, I'm to the point where I need to start by going down. I need to start down here. So the original cosine function started with an uphill, right? It started with a crest. Now your first point is a trough. So let's make that a negative 4. All right. Okay. Now, since that's not a lot of information, I want to just touch really quickly on absolute values. This goes back to the very first lesson we did this year when we started graphing and absolute values, how to tell if something is even, odd, blah, blah, blah. Number 4, the absolute value of 3 cosine x. When you do the absolute value of 3 cosine x, it's going to take all of your y values and make them positive. All of your y's are positive. Which means that if it is below the x-axis, you are going to flip it up. So let's see what this looks like here. First off, 3 cosine x. It starts off from 0, has an amplitude of 3. So here's going to be a point. All right. And then you continue on here. Your full period here, since there is nothing in front of cosine, your period is, or your value for b rather, is 1. So the entire period is going to be 2 pi. So it's the same cosine function, we just changed it now to be absolute value. And then halfway between pi and 2 pi, you remember we came down here and did a trough, right? This is where the point was. But since I have an absolute value, I'm going to take this point and I'm going to make it positive. Oh man. And then halfway between the crest and the trough, halfway between here, pi over 2, it hits the axes again. 3 pi over 2 hits the axes again. So I want you to see what I'm about to do here. Don't draw this just yet. But this is what it used to look like, right? With that little dashed line. This is what it used to look like. But now I'm taking the absolute value. So anything that's below the x-axis, I'm going to flip straight up. Again, if it's below the x-axis, I'm going to flip it straight up. So that means this is what it's going to look like now. So this bottom part is no longer here. Okay? Let's continue the same points over here. We were here, or we're still here at pi over 2. Negative pi, we would have been down here. So I'm going to put a little x right there. And then 3 pi over 2 is okay. And then at 2 pi, we'd have been at 3. Now again, it did go like this, right? It did sloop down, but now that it's an absolute value, I'm going to go up. All right. And very quickly, you can check this on your calculator. I'm going to do this just real quick. All right, so you can go to second catalog, and ABS is absolute value. Cosine, or whoops, 3 cosine x. And then let me do my window here. My window is going from negative 2 pi to 2 pi. That's already set up. Your y min is negative 4. Your y max is 4. Your x scale is pi over 6. Check that out. Follow the bouncing ball. Okay? And let me see if I can get this last one done here. 3 cosine absolute value of x. Now this one's actually interesting because the absolute value is strictly around the x. If you'll remember, this gives you a y-axis reflection, right? A y-axis reflection. So what I'm going to do is graph the right-hand side of the y-axis and then flip it across to the left-hand side. That's what the absolute values of x mean. So 3 cosine x, so your points are still here. Pi over 2, negative pi, or excuse me, pi, 3 pi over 2 and 2 pi. Right? And then I'm going to flip that across the y-axis. All right, well, notice that there's no change. There's no difference between the left side and the right side. The left side's already a reflection of the right-hand side. There's no change. And there's no change because cosine is an even function. It already has a y-axis symmetry to it. So there's no change to the cosine function because, again, it has a y-axis symmetry already. Cosine is already symmetrical across the y-axis. So if you reflect across the y-axis, obviously it's going to end up being the same thing, right? And then checking this on your calculator, go to y equals, I'm going to delete my absolute value. I'm going to go over here and insert an absolute value of x. And there we have it. The same graph we started with. Just to prove it to you, watch this. 3 cosine x. See, it's graphing here, the little thinking bar. It's graphing, but it's graphing right on top of it. Okay? Now, a quick note, since we've got some time here at the end. A quick note about your window. I want to go through on the... Let's bounce back and forth between a couple of these. Let's do number 1 here. I want to graph number 1. I want to graph 2 cosine 2x on this window. Well, this window, I look at it, well, actually, it's already set up. Never mind. Let me do this one down here. Let's say we switch to number 2, and I want to graph this window. Okay, so I'm going to go to my y equals, clear these guys out. And I'm going to type in -3 sine of pi over 2, pi over 2x. Right? Negative sine of pi over 2x. And then I'm going to go to my window. And look at the window of this graph. I'm going to make my window match this window. So it looks like it goes from -8 to 8. I could do just -6 to 6 if I wanted to. My x scale. Now this comes from the points that are on the x-axis. Notice how your x-axis is broken up into halves here. So I'm going to do 1/2. Y-min is -4, Y-max is 4. Your y scale is 1, so I can leave that alone. Graph it. There's your graph. Okay, so you can piddle around with windows a little bit. Just remember that the x-min is going to be the farthest left on your graph. The x-max, obviously, the farthest right. The x scale is what the x-axis is broken up into. So on this one up here, if I wanted to go back and set up this graph, right, I would do a x-min of -2 pi. Hit enter. I would do an x-max of 2 pi. Hit enter. And x scale. Now this is broken up into 1, 2, 3, 4, 5, 6 pieces of pi, so that's going to be pi over 6. Your y-min is still -4, still +4, still going up by a scale of 1. And then that would be this one. Now I didn't type in the correct function for it, but you get the idea. That's the window for that one. Okay, so just a few little helpful hints about graphing with your calculator. The trickiest guy on here is that x scale, making sure that this guy is right for how your x-axis is broken up. All right, y'all have a good one.